Hi everybody, this is Duke with a video on this tuning assignment. I guess I should probably call it black box since we're not really doing any tuning yet, but this is getting you started for some of the steps into how you could do some tuning on your FPV drone. So in this assignment we're using the Black Box Explorer, which you used to be able to download and run locally. There's still a version you can do that with, but now they have it as a web tool, so like this. Okay, and you can load your logs in that way. They do still have the source code, so I'm sure you could build it yourself and run it locally if you wanted to, but I imagine most people just run it in the web app. And so I'm going to use the Black Box Explorer web app here, the tool, to go through this assignment. I do want you to make sure before you do any flying for this assignment, make sure your black box is set up properly, okay, as documented in the video linked here. Just make sure you've done that before you try to fly and get black box logs for this assignment. Okay. You're going to use your own log for this assignment, so I don't have any logs for you to use. You're just going to load up one of your own, and then you're going to go through some of these 4 items right now in this video to help you understand what you need to be doing. So Black Box Explorer, when you open a log, you'll find your log. In this case, I'm going to use this log right here. It will load the log in, and it will show you something like this. So maybe a couple different things there that look different on your screen, but I'll go through a lot of the navigation here in just a second. So over here on the top bar, we have this overlay. So this gives you little overlays into the graph viewer, basically. This one, analyzer display there, okay? Let that one turn off for now. You can do playback. You can just like watch the log live. And while you're watching, you can speed it up so it plays, at 2 times speed, or slow it down so you can make sure you catch everything. Or you can just kind of click and drag and scrub through the log itself here as well. You can zoom in so you can see more details. It kind of expands. It makes the log, doesn't make it longer, but it zooms you in so it would take longer to view it essentially, if that makes sense. Okay, leave that back about 100. And you can manually jump to a specific time in the log if you want to. Workspace is basically a bunch of presets you could set up if you wanted to use this tool a lot. You had presets for certain things you wanted to view easily to load them all at once instead of having to do it manually. You could load presets up there. I'm not going to worry about that right now, but you can do that if you'd like. I skipped over these ones on the left-hand side. The home view, okay, is the graph. We have a log header and a table. Okay. Log header gives us a lot of the same information we would see in Betaflight, though in a slightly different format. But if I go in here, I can see all these values that I had on my copter when I was flying this log. And so, for example, if I go down to my rates, you can see my rates while I was flying right here. Pretty much default in this flight looks like. Okay. You could see what my motor protocol is. You could see what kind of receiver I was using, all that kind of stuff you can see in here, what was turned on, what was turned off, etc., etc. So all of those things are visible here in the header, okay, log header. And if we go to the table, it's going to show us a lot of values as well, and we can see these change as we scrub through the log. Okay, so kind of, I mean, I guess it's more of a live view, and to some extent you can scroll here. And if you look at our RC command, you can see what I was doing with the sticks, changes over the course of the flight, obviously, as I'm flying around. We can see our amperage, our battery voltage, all those kinds of things as we go through the log there. So that's kind of a live values view, whereas the log header is just, this is what the settings were when you did this flight kind of thing. Go back to home, we can go back to the graph view. All right, so that's the kind of the top bar there. You can, I don't have this set up, or I've never actually done this part of it, but you can also load a video file in. Say if you had DVR from your flight, you could load a video file and you could have the log overlaid on the video. So instead of this black behind the log here, black screen, it would be the video from your goggles or from your onboard camera or whatever it is, which is pretty cool. But I don't have that ability to do that right now to show you, so we'll just leave it as the plain old black background. Okay. Over here on the right hand side we have this legend, and you may have nothing here like this. Okay, but you can go down to graph setup and you can add graphs. So these are all different things you can see during the from the log that were happening during the flight. We'll look at some of these for the assignment. But for example, let's just look at our motors. Okay, it labels the axis motors, it chooses some fields for us, gives us a color. You can customize a lot of this thing. Say, oh no, I want it to be yellow. That's fine. Okay, you typically can just leave these smooth and expo alone here and say apply changes. Okay, and we get the representation of our motors in flight as we go through the log. If you hover over one or the other, it'll show you what's going on. But as the flight moves, we can see the graph. We can also see the percentage over here changing as we get different percentage of throttle, or I guess RPM, from each motor. Okay, so here I think, let's see, somewhere around here I did a flip. Yeah, right here. So we see the throttle drop, and two motors go kind of higher to flip the vehicle over. It flips over, and then we get back on the throttle, a blip there, and level out and flight again. Okay. So that can help you see things what your motors are doing. If you have one motor that's way off the others all the time, then there may be something wrong with your motor or your ESC. You can also see the stick overlay up here. So that's what my transmitter sticks were doing when I was flying. You can see there's my throttle moving up to kind of a blip, down, right stick over to do the flip, and then back on the throttle, and kind of into another hover after that. Okay, and so you can see those different values changing as you look at the log and have the graphs appropriately set. If you go back to the assignment, ask you to do something with a flip. If you haven't done a flip, then I give you an alternate. Okay, but we have to pick a different graph setup to do what I'm asking you to do here. So I say using gyro scaled roller pitch. Okay, let's take a look at that. Go into graph setup, and we can go ahead and let's remove this graph for now. We'll just add another graph. We're going to go into gyros. Okay, and you have all these different types of gyros here. So even though the graph is called gyros, we can still select random stuff in here if we wanted to. Let's go to gyro roll and hit apply changes. And that's what I'm talking about right here. Actually, sorry, I said gyro scale. Let's change that. That's my bad. Graph setup, not gyro. Let's do gyro scaled. Where are we at? Gyro scaled roll. There we go. Apply changes. Okay, so the kind of difference here, it's a little bit interesting, but gyro scaled is the raw gyro. That makes sense. What's the gyro and the flight controller is actually experiencing. Whereas if we added in, if we added in the other one that I had a second ago, gyro, just normal gyro. Okay, it's after the filtering's applied. And so in the second part of this, I'm going to actually have you do that a little bit with the gyro. But right now we can look at this and see my gyro here. So let's actually zoom in a little bit. This is where it can be beneficial. You can see there is some, vibrations. There's some noise that's getting to the gyro. These little these red lines up and down, up and down. And you can see that in the gyro scale because it's kind of like the raw values, whereas the gyro roll, not scaled, is just what the gyro is seeing basically after filtering's been applied. Okay, and so if we go zoom back out, we see during my flip, the gyro saw a big rolling movement. Right, this is a roll axis of the gyro, so it goes high and it goes back to center. You can say as we go back into a normal hover. You can see that happening all throughout the flight as I do different maneuvers or things like that. Here's another one back here. I flip the opposite direction, so the gyro goes negative. So this is what you can kind of see here. It was a left-hand flip, okay, versus a right-hand flip. The gyro sees positive or negative in that sense. All right. So in the assignment, in the assignment here, we want to point out the section of the log where we did a flip. So you would take a screenshot and say, sorry, I keep flipping back and forth. I'm used to having a different window. You would just take a screenshot and say, look, here's where I did a flip. This portion of my log is where I did a flip. And you can see the gyro over here, got it pulled up, so on and so forth. Okay. Let's do this next one, a screenshot of your gyro roll pitch and the corresponding set point. Okay. So set point is what we are commanding it to do, and then we see what it's actually doing. So let's go ahead and find set point in here. Set point for roll, and then the actual roll basically. Okay. Excuse me. And so we see gyro set point roll or pitch, depending on what kind of flip you're doing, and set point roll or pitch to see how well it's responding to the set point. So is the quad actually doing what we're asking it to do? So we see the set point here is in red. Okay. And so that's what I was doing with my sticks. I was moving and I have a little bump here and probably wasn't very smooth on the sticks there right at that point. And I'm commanding it to do that, and we see the green is what the gyro is actually doing. We could turn on the gyro uh, scaled roll as well, kind of just compare all three. Okay. And if we zoom in to a section here, we kind of see that, let's take this beginning section for example. Okay, so red is what I was telling it to do. Yellow is what it was doing, basically what it was measuring before filtering of what it was doing, and green is what it's measuring of what it was doing after filtering, if that makes sense. Okay, so we see that it's lagging a little bit. It's not as crisp as it could be, right? It's not following the set point or what I commanded as easily as or as nicely as we would like. This copter is not really tuned at all, so the defaults behavior get us kind of close, but there's always room for improvement. And then we see that it overshoots a little bit here of what I commanded, then it kind of comes back. And then we get over here to the end of the maneuver, and we command the other movement, and it lags a little bit again, kind of fits in there, lags again, and then we start to get it more aligned here as we level out the copter. We do have some over and undershoots things here where the desired state of the vehicle is not what it's actually doing, and there's some error there between the actual and desired. That would give you a screenshot of this, okay, what you want to look at there. Okay. The next one, we're going to go ahead and look at our update rate of our RC link. So we're going to go to graph setup. We're going to just clear these, and we'll just add a new graph. And let's see here, RC command. Okay, I want to go to what it is. RC command, yep, roll, pitch, yaw, throttle, whatever you want to use. Okay. And so we will go to RC command specifically. Let's just use roll in this example again. And we'll say apply changes. And we see this, let's zoom out a little bit. Here's our RC commands. Okay. Kind of in terms of packets, if that makes sense. So digital packets that are sent from our transmitter to our receiver, the flight controller receives them and logs them. And the purpose of us doing this in the assignment is to help you use what's called the measure tool to measure things on the graph. Okay, so let's zoom in a little bit here and go to one of these steps. So like right at the beginning of the step there, or close as you can get. You're going to then hit the M key on your keyboard, and it will give you this marker. And then scroll over to where the corresponding start of a step is here, okay? And you get a measurement, okay, in terms of hertz, 48 hertz. So we could say that my update rate on my transmitter to receiver link at this point was about 50 hertz. And you see that's pretty consistent. So if we hit M key again, it will undo that measurement there. Pretty consistent in some areas here. You can just take a measurement and see what you get. It should be close to what your update rate or your packet rate in Express LRS is, what you have set in your transmitter. So if you're doing 150, it should be close to 150, 250, whatever it is. It should be fairly close to that over the course of measuring. But the idea here is just to get you to use the measuring tool so you can practice a little bit how to use that. All right, so you screenshot that, show me, yeah, Duke, it's 50 hertz, whatever it is. And then you have this last one here is a little bit different. We're going to use the analyzer display and use frequency versus throttle to find where our motor frequencies are. Okay, so that's not exactly in here. It's actually the analyzer display we haven't used yet. So it'll kind of pop up here in the corner. There it is. Okay. Now to make sure we get this correct, we want to use the analyzer display while we're viewing gyro scaled, it could be roll or pitch. Okay, we don't want to use the analyzer display while we're doing our RC command view because it's going to affect the view. I'll kind of show what I mean here. So let's go to this expand here. You see we have all these little peaks all over the place. Okay, this is the vibration or noise uh, that's present in our copter, and it's showing it in hertz here, okay, along the bottom, and then we have amplitude along the side, right? But let's change the graph to be one of our gyro roll um, parameters, scaled roll, okay? And once it, there we go, applies the changes, we'll get a much different graph. And so when you're looking for noise on the vehicle, typically you're going to look for the gyro variable, so you can see the noise that's present on the vehicle that was measured by the gyro. In this view, we have a couple different things we can do. There's a slider here. Oops. That is a different, that's not working how it used to work. Interesting. Let's try this. Yeah, that scales like it used to. I'm not sure why this one's not working. Strange. Okay. Usually you can drag this up or down to increase or decrease the amplitude. I wonder if we reload the page, if it will help us do that. This is my first time using the web-based viewer, so let's see if we get a better result here. Huh, I'm not sure why that's not doing anything. That's strange. Well, anyways, this will give you an idea of where the noise on your aircraft is at in terms of vibrations and things like that. But actually for the assignment, I want you to use not just the frequency graph, but the frequency versus throttle graph, okay, here. And so this is where it's going to be more of an issue to not be able to drag this up or down. It's kind of annoying. I don't know. Maybe I'm just not using it correctly or something. But we will go ahead and operate off of this for right now. We can see here this graph, frequency versus throttle, is what's called a waterfall plot, I believe. So it still has the frequency along the bottom, amplitude of sorts along the side in terms of what our throttle was at, our throttle percentage. But then also there's the kind of third dimension coming out of the screen, we could say. So we have this reddish area here, the rest of it's black. We have this white over here, and then reddish, then black. So you might guess, and then you'd be right, that the white area would be like the largest amplitude in terms of how much vibration or how much noise. And then it kind of goes to a reddish, to a dark red, to a black, being no noise or no vibrations in those areas. So this allows us to see there's some vibration kind of in a band along here. And we can see, because we have the throttle percentage on the left-hand side, that the band moves up as we move our throttle up. So it's some kind of noise or vibration that changes with throttle, right? Now, what would that be on a quadcopter? Typically, it's the motors, right? Because the motors will speed up or slow down depending on our throttle. And as we increase the throttle here, the vibrations move into a higher frequency range. So from low frequency to high frequency, okay? And we can see that there is a good amount of vibration here because of the reddish color here. There's kind of a big splotch there. A little bit more down here, but it kind of goes up in a continual movement. And so if you look at that, you say, well, that's probably my motor noise, okay? That's moving in this manner, okay? And if we go back to the assignment, I just want you to try to determine where your motor frequencies lie. So you would be saying, well, Duke, my motor frequencies, vibration noise lies right here. It's in this area. Again, I'm just trying to get you to basically use the tools in the black box log viewer in order to do this. I really don't know why this button isn't working. It's really nice to be able to drag it up to kind of increase everything and be able to see things better, but maybe I'm just not using it correctly. I'm not sure what's going on there. Okay, so this would be the motor noise versus, or motor throttle versus motor noise kind of type graph here, and it shows those frequencies like we just mentioned. So I hope this video helps you get through the assignment and get some basic understanding of the black box viewer. Of course, we'll do a little bit of this in class. You can ask questions if needed. We'll use this tool a little bit more in the coming weeks in class to give you a little more familiarity on what's going on. So hope that helps. Thanks.